So I would ask all the speakers of today to join me here so we can continue a fantastic panel discussion that we already started. And again, I would love for our audience to type the question in the chat so we can also pick them up. I think we are waiting also for all the other speakers of today to join. Matei, Stephanie, and Michael, and also the speaker of this morning. I'm sure maybe this change was like they were not prepared to join
party
again.
now. Party
Sorry?
time.
Yeah,
we can
party
have a
time.
party.
Yeah, that's definitely a good
I
time
got a
to
beer.
start.
Oh, nice. Is it German beer or a Spanish one?
No,
Spanish
that is
beer, of
Spanish,
course.
definitely
Okay.
Spanish.
Estrella.
Oh, okay. Yeah.
So I hope like all the other speakers can join, or if they are, we give them maybe 1 minute. Yeah, definitely. I think we need to maybe wait for the other to join. But definitely we can continue to discuss like what we were, I mean, starting before. And I mean, Hiroki, your approach is like really computational. So it's from the side of the, let's say, software. Well, of course, Oliver is like definitely focusing on the aspect of embodiment. And so it would be interesting to understand like how you two things like that we can continue to foster and enable communication between these two communities. So how, I mean, do you think like, for example, from your perspective, Hiroki, you can integrate something that maybe you saw during the amazing talk we have in your work? I see a lot of connection between, for example, your work and the work of Michael, in the sense that potentially what you do can become, for example, something like that goes to the base of simulators that can be used maybe for him to perform his study even before to actually, you know, try all these possibilities. But I would love to know if you also saw other connection with the community that is like working more on the aspect of the embodiment.
Yeah. So I'm kind of the outsider compared to the this community to the community. So I don't really work on actual robotics, but there's definitely the potential connections between the embodied robotics type of the research and the currently mainstream computational approach. By the way, I'm also the outsider to the current AI LLM kind of stuff. I never touch LLMs. So, but just like some of the comments posted in the chat earlier today, we can consider each other's kind of the useful concepts and tools. We don't really have to create any boundaries, and then people can get excited to use any toys that we can actually borrow from the currently popular AI LLM machine learning tools. So one example I like to mention is that my close friend, I don't know how many people are familiar with the artificial life field, but Takashi Ikegami is a very well-known guy in the University of Tokyo, and he does robotic stuff in collaboration with Hiroshi Ishiguro at Osaka University. They build that physical, very humanoid kind of robots. So in that sense, it's a very much embodied research and also the art creation. Takashi does some serious art installation by using those kind of robots. But one of the things he get excited when LLM came in is that he just connect that robots to LLMs. The crazy idea, no configuration whatsoever. That he just let LLM to control the robotic behavior. And that what he discovered was, even without using any training, and there was some body-related information encoded in the human-generated documents. So there are, billions of the text and documents accumulated by a human, in the past. That large amount of text data somehow encoded a little bit of the embodied information, so that his robot started behaving in a more meaningful way. So that gets him very excited, even though he is a very much embodied robotics kind of researcher. There is clearly interesting stuff, not the entire embodiment, but some part of the human body, recognition kind of information is encoded in the text data. So that is one way to utilize LLM in the current very simple framework. And I'm sure there are many other ways to connect what is currently popular in the AI with more embodied systems. So this is just one example I want to mention.
Yeah.
Yeah, can I
Yeah,
just,
please,
I
Oliver,
mean,
yes.
so I find it very interesting, and we've actually done the same thing. We've connected a whole fleet of the most current large language models to our robots, to very interesting results, I thought. But maybe a comment back to you. It's true, of course, and that the body of knowledge and text created by humans includes information about embodiment. But the conclusion that we are coming to, we're still in the process of evaluating the data, and I'll tell you about some specifics in a second. But the conclusion that I've come to is that, and it's not very surprising, that the large language models include and can regenerate statistics over the entire body of knowledge.
Yeah,
right?
true. Yeah.
So when you then start applying this to a specific case, you're actually not interested anymore in some average statistics. You're interested
Exactly.
in this one particular case. And if everywhere in the world, people drive on the right, and then there's a country where people drive on the left, well, things will go wrong because that's not the average statistics. So
Yeah.
what we did is we actually studied, behavioral biologists have an experimental paradigm they call lockboxes. These are mechanical puzzles that animals have to open, and they do this with cockatoos, with apes, with elephants, with raccoons. And so we started doing this with robots, that robots have to explore a particular mechanical puzzle to open it. And so we had humans do it, and we had robots do it, and now we have large language models do it. And I was surprised actually how well they do up to a certain point. And then they completely fail, and there's no way they can recover. You can tell them, no, you're wrong. It's actually not open. And it just starts believing in its own world. So it has really, really fundamental difficulties dealing with instance specific information. Right? As
Yeah.
long as you stay general, it's really impressive. But instance specific information it cannot handle. And so this is a fundamental question now that gets raised. Are the mistakes that we see right now just small things that will be removed over time as these large language models progress? And this is what everybody seems to be believing and is claiming. Or is there a fundamental flaw that will make it impossible to get to these instance specific situations? And yeah, I mean, I don't know, but I can tell you that if you watch the progression of large language models over time, because we've tested old ones, we tested the new ones, we tested the thinking ones, and so on, there's absolutely no change with respect to these performance characteristics. They all perform the same. So I would say that at least currently we're not on a trajectory where large language models are capable of doing instance specific reasoning well.
I agree 100%. Yeah. I'm actually in the second camp. I never get impressed by any output of the generative AI or large language models. Everybody gets excited. I am not. So I agree. Yeah,
sometimes
100%.
it's impressive, right? I mean, I get surprised. I have to say it's amazing. It's
Yeah.
pretty impressive.
Yeah.
But
Yeah, go ahead.
You.
Okay, so the recent days, the big boom of like the Studio Ghibli type of the illustration, the AI is using it. Everybody is so fascinated. I hate it. Absolutely hate it, because you
Yeah.
convert by using AI, you lost your individuality. Every picture looks the same. Yeah, so I don't know why people are so excited about the Studio Ghibli AI generator. I absolutely do not want to try it myself, because individuality, uniqueness is completely lost. It's all average Ghibli face.
Oh.
Yeah.
It's
Anyway,
like
so
that we are losing, like, actually our diversity is actually
exactly.
what
And that
makes
comes
us
to
survive.
yeah. And I think that I personally believe the embodiment is really about the specific case, right? This is my body, this is your body, and then every pattern is very unique to the physicality. And that is definitely not captured in the large language models or
Can I
gently.
ask you
Yeah.
something about,
Yep.
because I mean, like, your work actually consider all the different units are the same. Have you explored also, for example, different morphology within your simulation? So, and how this behaves, for example. So, I mean, we are claiming that diversity is important, and for example, today we discuss also with Mons and having two different embodiments with two different capabilities, like coordinating to and collaborating to achieve a task. I mean, this concept of diversity actually emerged as something like that is successful. And today you show us your simulation where actually all the agents were the same. So they were the same within the certain, let's say, so you were trying to combine them, but that they were like interacting within the same species, let's say. So did you try instead to look at like completely different
Well, they
morphologies or
are actually,
capabilities?
yeah, so they are the same in terms of physical shape, because they don't have a shape. So it's basically a point math, right? They don't even have any radius exclusion. Every single agent in my simulation is a point. It's XY coordinate. So, but they are very, very different behaviorally, so that the behavior parameters are assigned differently from one particle to another. So in that sense, they are already very diverse. We simply do not have the physical morphology assumed in the simulation system.
And do you think this could be something interesting to explore?
Yeah, definitely. Yes. Yeah, biological cells have many different morphologies. We can definitely consider that, but that actually complicates the model quite a lot.
Yeah, I
Yes,
think like that's probably is also the one of the problem, like for Michael, I guess, to be able to actually have this kind of simulation tools to support his research. Sorry, Oliver,
Yes,
please go ahead.
Oliver.
I just wanted to say that there's a question in the chat.
Yes, like Dana.
Yeah.
Dana, that if you want to join the panel, we would love to have you here as well. But I mean, or if you want to turn off your mic and ask the question yourself. Otherwise, I can like repeat it for you. I'm sure if you are there. Maybe I can start to just like say what Dana was asking. So she said like we typically ask how intelligent robot is. I wonder if we think about embodiment in such quantitative ways and what the panel think this could be. For example, could we say that a robot is more embodied if they are sustainable or less breakable? There might be some biological inspired principle to develop our dialogue around embodiment, not just as existing fixed substrate for intelligence. What the panel think about this is some of you want to pick it up.
Oliver, would you like to try answering this?
Sure, I can try. First of all, I'm not exactly sure I understand the question, but I think the question asks us to kind of come up with a clear understanding of embodiment. That even goes so far to say that there should be a quantitative way of evaluating the degree of embodiment, and that should be a number, right? Which is kind of radical almost. And I think that's a good question to discuss. My answer would be that I don't think that exists, because I am questioning more and more whether the term embodiment and what I kind of intuitively mean by it actually is a scientific concept. Sorry to say that, but so I would love to hear what people think would be quantifiable about embodiment. I'm a little bit of a skeptic now, having thought about it for a while.
I'm relatively new to this embodied intelligence concept. So my understanding so far is that the intelligence that is basically embedded in the certain kind of situations. This includes its own body, if there's any physical body, as well as the physical environment. So that's my current understanding. Is it more or less accurate, Oliver?
I don't know.
Yeah.
I don't know, but yeah, I mean,
Yeah.
this is. I would love to hear also from the people that are still out there.
Yeah. I would
What
like
they
to
think.
learn more. Yeah.